from the Free State 2014 September. Question 8. In the circuit diagram below, resistors are connected in parallel as well as in series. The battery has an EMF of 24 volts and an internal resistance of 1 ohms. When switch S1 is closed, the reading on V1 is 21 volts. Let's analyze the circuit. The longer arm of the battery is your positive, and the shorter one is going to be your negative. So the total current will flow in this direction. Here you will still have the total current. When the current gets to that node, it will be divided. So you will have I1 and then I2. So nothing has been said about switch S2. So S2 is currently open. So let's cancel that part of the circuit for now. So resistors in series will have the same current. So we will still have I1 passing through the both of them. And then at that node, I1 and I2 are going to combine again to form I total, which will be the current that will pass through the 3 ohm resistor. So this is the I total. 8.1. Explain in words the meaning of a potential difference of 21 volts. In your formula sheet, you have this equation. So V should be equals to W over Q. So this is 21 joules of energy that is required to move 1 coulomb of a positive charge. So you will say the work done, the 21 joules of work done in order to move 1 coulomb of a positive charge. .2.1. Calculate the reading on voltmeter V2. So the parallel combination is connected in series to the 3 ohm resistor. So let's just combine all of those resistors. So that parallel combination will be parallel to the 3 ohm resistor. So this is the R parallel. And then for resistors that are connected in series, they will have the same current. So through here you will have I total as well as there. But the potential difference should be different. So there you will have V2, and then there you will have V through the 3 ohm. Okay. Let's find the total current. EMF should be equals to IR multiplied by R. So IR, that's the V external. So I'm not going to change this part because I do have the internal resistance. So the EMF should be equals to 24, V external is 21,0, and then I don't know, but I do know that the internal resistance is 1. So I total should be equals to 3 amperes. So I now have the total current through the 3 ohm resistor. I can find the voltage. The voltage through the 3 ohm resistor is equals to I multiplied by R. The current is 3.0 and the resistance is 3. So I have 9 volts passing through the 3 ohm resistor. So the voltage that is registered by V2 plus the voltage that is registered across the 3 ohm resistor. When you combine them, you should get V external. So that's 21, that's a 9. This is V2 plus 9. The V2 should be equals to 12 volts, 8.2.2. The power dissipated by R. So there's a couple of methods that you can use in order to find the answer. Let's see what we come up with. So in the first method, I'm just going to focus on the parallel combination. So I will have that so you have I total coming in this way, and then you have I1 and I2. And then you know that V2 is 9 volts. So let's find R series. 4 plus 2 should be equals to 6 ohms. Okay, and then you know the voltage through those two. So I1 should be equals to V all over R. So the voltage is 9. No, the voltage is 12, not 9. It's 12 over 6, which is equals to 2 amperes. So when you combine I1 with I2, you must get I total. I1 is 2, I2 and 3. Therefore, I2 should be equals to 1.0 amperes. And then the power should be equals to, so you have the current as well as the voltage. This is 12 and then the current is 1. So the power should be 12 watts. That's option 1. Option 2, we can find the R external first. So the EMF is 24, and then I total is 3. So that's R external plus the internal resistance is 1. So R external is 7 ohms. And then R series, which is the 4 and the 2, should be equals to 6 ohms. Then we'll find the parallel combination. So that would be the 6 ohm resistor multiplied by the R all over 6 plus R. And then the parallel combination is connected in series with the 3 ohm resistor. So R external should be equals to R parallel plus R external 7, R parallel is 6R over 6 plus R plus 3. So that's a 4, 6 plus R, 6R, 6 times 4 is 24, plus 4R, R. Therefore, R should be equals to, so I'm getting ohms. And then from this, you can say power should be equals to V squared all over R. So the voltage through R, V2, that's at 12. And the resistance is 12 as well. So 144 divided by 12, that's a 12. So yeah, they are the same. .3. Switch S2 is now closed. Let's clean that up. So now you are closing S2. How will the power dissipated by the 3 ohm resistor be affected? Write down only increase, decrease, or remains the same. Explain the answer. So we are adding a resistor in parallel. That will cause the R external to decrease. And the current increases. So we are not changing the resistance of 3 ohm resistor. So from power is equals to I squared multiplied by R. We are increasing the current for the same resistance. So the whole product should go up. So the power